Hello, my name is David Binder. I'm from Yamaichi and I welcome you to this presentation, 5G-driven developments for pluggable connectors. I thank all the attendants for their interests and the optical connection team for having us. Yamaichi Electronics is a member or reviewer of many MSAs. As a highlight, I can mention we provided the leading design for DSFP, NGSFP and NGSFP-DD, the dominating form factors in the 5G rollout. 5G is a game changer. Fiber goes to the antenna and is replacing copper-based coax cables, which means this is a huge opportunity, not just for us as a connector maker. This is the next generation of SFP form factors in 5G as we see it. Some companies are still with SFP28 but will move to SFP56 or SFP112. Other companies already moved to DSFP and NGSFP. And in the near future, we think NGSFP-DD will be most important. Choosing the right form factor isn't always easy. Technical parameters can conflict with each other. Backwards compatibility conflicts with data rate, with dimension, transmit power, with heat dissipation, etc. But technical parameters are not the only problem. Also, different MSAs can create conflicting interests. If your product targets the Chinese market, it is an advantage or even mandatory that your product complies with the Chinese MSA. We, as Yamaichi, want to serve both markets. And that's why we developed DSFP and NGSFP, a connector that comes with a multi-fit feature and is backwards compatible to SFP. You can use the SFP cage and all your legacy tooling, also your customized cages and heat sinks, etc. But you have two channels capable up to 112G. The comparison between SFP and DSFP, respectively NGSFP, is easy. The outer dimension is the same, but there is some empty space in the SFP design. And in that empty space, we placed in 2 additional pins. By adding 2 additional pins, we added 1 channel on top and created it a dual channel form factor. The bottom view, you can see, is almost identical, except for the 2 pins. Let's have a close-up. This is the front row of the PCB pins, and you can see all the pins are identical except 1 additional pin here on the front row. What about double density? Well, double density is an approach to achieve backwards compatibility. You have a legacy row at the front and a double density row at the end. But the double density approach comes with advantages and disadvantages. Of course, as the name already indicates, you have a higher density, but on the other side, you have a higher soldering complexity and the design is more vulnerable to crosstalk. We think 112G in particular is challenging for a DD approach. Yamaichi's proposal of an increased distance between the legacy row and the rear row have made 112G possible on a double density form factor. This according to our proposal of NGSFP-DD. The outcome was a form factor that is mating compatible with 4 modules, and this up to 4 times 112G. Let's talk about the throughput of form factors. On the top, you can see data center form factors, which are considered to be too large for 5G fronthaul applications. So the lower 4 form factors are those who are relevant in 5G, according to our opinion. NGSFP-DD, SFP-DD, DSFP, and SFP. And you can see that the throughput in this scenario for NGSFP-DD outperforms all the other by far. SFP-DD here is assumed to be only a 56G form factor. Key takeaway: choose the right form factor. Go for DSFP, NGSFP. Keep the SFP footprint, the cage, but get up to 2 channels, up to 112G. Or optimize without compromise. Give up the SFP footprint and cage, but go up to 4 times 112G. If you have any questions, please contact me. If you are outside Europe, please get in touch with one of our local sales offices worldwide. Thank you very much for your interest.